So I'm gonna start with the science behind spontaneous fermentation. All the work I will present you is made in the French Institute for cider production. We are located in the far west in France, Bretagne and Normandy. My presentation will go through a quick presentation of the French industry, our institute, and then I will go through the cider making in France, so with the different steps, and I will try to explain you what you have to control during all those steps, and a quick conclusion on the key points you have to remind. The main production of specific apple fruits are made in the far west, like I said, so that's a big circle. It's Bretagne and Normandy, but there is some other regions where we can make some cider. 90% of the production is in Northwest. We have two different orchards. So one is typical meadow orchard, that's tall trees. That's something typical in France. We'd like to have this image of cows or some other animals under the trees. And there is a more intensified orchard made in the 80s. And it provides the biggest production in France. Some statistics. So it's about 250,000 tons a year. And most of the apples are processed in cider. But we are making more and more apple juice. And there is a part who goes for the spirits, the vinegar, and some other products. So it's about, for the cider, it's about 1 million hectoliters per year. 80% of the production is made and processed by two big companies. So it's a little bit different from the shim in America. And 20%, the last 20% are made by craft cidery, so smaller size cidery. And then, well, there is a definition of the cider in France, and we have to have a lot of fresh apple juice. The concentrates are very limited in France, so we try more and more to work with pure juice, apple juice. We have a structure of the cider industry, a specific organization. And so there is, in the middle, you can see Cidre de France, that the interprofessional association, the National French Cider Association, and that regroups all the apple grower and the apple transformers. You can see on the top. And each people have a tax, something like a tax, a compulsory, a voluntary contribution that helps to make a collective promotion of the cider, so for all the cider industry, but also the technical action, the collective research. And that's the part we are going to talk today, that the IFPC way we finance this institution. Well, it's about the third of our budget. And you see we are a very small company, in fact. We have 12 people, permanent people. And well, we are hiring some people to help us on some different tasks. That's the reason why I put 15 employees, including 12 permanent people. And it's about 1.5 million euros budget a year. The French Institute, two different locations in France. So one in Normandy. You see the orange point, based in C. That's a very small city in France, which is dedicated for the orcharding research. And we have a specific orchard where we make experiments to see, well, to work on different experiments. And there is a second location where I'm working, located in Rennes. It's in Brittany. And we have all the equipment to work on the transformation from the apple to the product, cider, juice, and so on. So the apple production is kind of specific in France. And the work we have to do with that the part is making in Normandy, they are working on the creation of new varieties because we're looking for different characters of the apple due to the climate changes. We try to optimize the production techniques and so on. So you have the listing here of what are studied in this location. For the cider making, we're working on the optimization of the processing. We are working on the yeast, on bacteria, to control a little bit more the fermentation. That's what we're going to talk today. And also different other characteristics, the color, the bitterness, all the savors. And we try to optimize the aromatic expression in cider. We have also, and I will talk about that today, we are working on the hygienes. All the cleaning techniques you have to really put in your cidery to have a clean product. So the processing. First of all, I wanted to talk about the apples and the harvest because it's specific in France. We have plenty of different varieties. So you can see on these schemes, you can have on this graphic, you have different category of apples that we can use in France. So it's classified by the total polyphenolic content that you have on one side, and with the acidity. And you can see that I put in the bottom of the graphic where are located the eating apple compared to the French apples. And you can see that it's very, very different concerning the polyphenol content. We can have some varieties like one I put here, Marie Ménard. Some of you knows the varieties already, but which is very, very rich in polyphenols. And another way, we have some other varieties that are very sharp, very acidic, like the Evrol. And you can see that we have plenty of different variety that we can put here. And that's all those varieties that we are using to make the balance in the taste of the cider, the French cider. So one point is, all the French apples, cider apples, should have a polyphenol content over 1 grams per liter in the must. So that's pretty important. And compared to the apple fruit, the eating apple, we have smaller fruits. Usually we have fruit around 45 to 90 grams per apple. So I put back the specificity of the orchard and the harvest. So we have selected a lot of different varieties. They are rustic varieties, meaning that they have a high polyphenol content and they are very resistant to some different, in the concerning the disease we can have in the orchard. There is no constraint of the appearance, so we have less product that we can put in the orchard. There is less insecticides and stuff like this. We needed to have a cost reduction in the production of fruits. So now we harvest. The harvest is almost done by mechanization by 90% probably. So that's a problem for the fruits because it can be hurt when you harvest it. It can be hurt by the machine that harvests the apple on the floor because we are waiting for the dropping of the fruit on the floor to be harvested. That's something a little bit specific, and we need to have a process very rapidly after that. So we're waiting for the natural fall of the fruit, which is about, depending the variety, is between September and December. But the main variety is falling around October, so there is a big moment where we have to work a lot. What we recommend to the producer is to be very rapid to process the fruit after the mechanical harvest. And normally, we shouldn't wait 3 days after the mechanical harvest to have a good processing quality of the fruit. Otherwise, we can have more and more possible contamination by spoiling microorganisms, and I will talk about that a little later. After we harvest the fruit, we have to carry the fruit to the processing machine. The carrying is made with water. That's a recycled water. During this step, we can have a possible cross-contamination by spoiling microorganisms. So that's a key point to be really aware, and we should be careful about that, because the microorganism can grow really rapidly in this water, and more with the climate changes, we saw that the increase of temperature is going to improve this development of microorganisms. So we have to be careful about acetic acid bacteria, Brettanomyces, and so on. That's really a big concern at this point. So I will go rapidly through these slides, because that's just the composition of a must we have. So that's just to show you the range of concentration we can have in the different elements: sugar, acid, polyphenols, the nitrogen component. You can see it's a wide composition, but the average of nitrogen, the YAN, is about 70 to 80 milligrams per liters. That's not a lot compared probably to the eating apple. And that's due to the fact that the orchards are not a lot treated with nitrogen, additional nitrogen. So we have a low nitrogen level, but it's very important in our context for the development of the aroma. And I will probably talk a little bit about that later. We are talking about the must. After we made the must, there is another step, the clarification. So there is different way for the clarification. For some products, for instance, the brandies, we don't have any clarification. Usually, we put the must in a kettle, and then the fermentation go on alone rapidly without any control. We can have a settling that's mostly used for the sour and sharp varieties, because the kiving that I will talk later is not possible on or very, very difficult to get on the sour and sharp variety due to the pH. When it's too low, the kiving is not working. And then the hydrolysis of the pectin is done to remove the pectin, and there is a setting of the pectin in the bottom of the kettle. And the other one, which is the more used in France, and due to the characteristic of the apples, we can do the kiving, so the clarification by a gelling of the pectin and a racking. So the pectin is, there is a demethylation of the pectin by an enzyme activity, and there is a gelling which is formed with a calcium addition, and this gel will separate and will go to the top of the kettle, what we call chapeau brun, brown hat in English. When the brown hat is made, we have to transfer the clear must in another kettle, another vat, to keep the clear must. That's the clear must that's gonna be fermented. That's a little experiment we made to show what is important in clarification. You can see it starting. So at the left, you have the control. In the middle, where you go, you see the fermentation very active. This is the same must, but with addition of Saccharomyces uvarum. And on the other step, that the same must, but with the addition of Ensenia-Spora valbiensis, which is another yeast that we found in French cider. What we have shown during this experiment, that the importance of this yeast, this particular yeast, the Ensenia-Spora valbiensis, because we need to have a gentle start of the fermentation to be successful in this clarification. When you see the three fermenters in the middle with Saccharomyces uvarum, the fermentation is so active, so rapid, that the brown hat is completely broken, and then the clarification could not be made at this moment. So we showed that there is an important yeast in French cider, but this yeast is very sensible to sulfite. So if you put sulfite in the must at the beginning of the fermentation, you will remove this specific yeast, and so probably that the fermentation, well, the clarification will be even pretty difficult to obtain. Another parameter is the low temperature. You have to have a low temperature to be succeed in this step. Well, usually in October in France, the temperature were quite low, about 10 degrees C. But with the changes of the climate, it's more and more difficult to have to keep this temperature. So that's a real concern with the changes that we are observing actually. So most people have now their cidery with regulation of the temperature to help all the process. I said we have a clear must, and now go to the fermentation step. We have different microorganisms that can help the fermentation. I talked about two of them just before. So in spontaneous fermentation, you have Mechnikova pulcherrima, which is a yeast that you can find on the apple, that's naturally present on the apple. It can have a small effect on aroma at the beginning of the fermentation, but as soon as you have a lack of oxygen, this yeast will gonna die. The second one, I talked about it earlier, Enseniaspora valbiensis. This apple grows as well on apple, but we can find it in the must. And it's very important for the clarification, but for the aroma as well. It has a very important esterification capacity that makes some aroma with fruity notes and so on. So this yeast will last for 1 to 2 weeks, depending on the conditions, and then it will decrease in the must afterwards. Then you have the Saccharomyces suvarum, the third important yeast that's gonna make the fermentation. So it's different from the Saccharomyces you can find you can buy and you can find in wine. In wine, you have Saccharomyces cerevisiae, and the condition of growth is completely different for Uvarum. Uvarum is naturally selected in the cider, in French cider, due to the temperature. I said that usually the temperature was around 10 degrees, and this yeast is able to grow quite easily at this temperature. So rapidly, this yeast become dominant and then conduct the fermentation. I wanted to talk rapidly about the main risk we have related to possible off-flavor formation in cider. There's the volatile acidity that is due to acidic acid bacteria. So, like the name of the bacteria, they're gonna generate acidic acids and ethyl acetate, which gave this specific aroma with this bacteria, which is not really wanted in cider. In French legislation, we have a limit level that we shouldn't go over. It's 1 gram equivalent sulfuric acid per liter. Another disease, the French sickness, why we call in French framboisé, is due to a bacteria, specific bacteria, Ximomonas mobilis, which is going to generate a lot of ethanol. And this compound have somewhere a specific aroma, a strawberry aroma, and red fruit aroma, and we call that framboisé. So, but there is a lot of other unpleasant flavors that can be developed by these bacteria, so we really don't want it. And most of it, in bottle, you can have a very, very high pressure. due to the consumption of sugar, this bacteria is able to remove a lot of sugar and to generate a lot of carbonic gas, which means that the pressure will be very, very high. We can see a bottle explosion, so it's very dangerous. The two other main defects that we can have in cider is the lactic acid spoilage due to a specific. So that's the new name of this bacteria, Secondly Lactobacillus collinoides. It was previously called Lactobacillus collinoides. Well, that's a new name that came this year. And this bacteria will be able to transform the malic acids in lactate and also in acetic acid, and this can be a problem for the aroma of the product. And the last one, something you probably know in the States, the phenolic of flavor, which is due to Brettanomyces. Brettanomyces anomala, its specificity of the cider is different from the Brettanomyces from wine. And this specific yeast, it's a yeast, it's not a bacteria, this specific yeast will generate volatile phenols that gave, well, the two main phenols are ethylphenol and ethyl catechol, that are going to give some animal flavor like leather. I will show you that a little bit later. So I will show you the different way the fermentation evolved in the French cider. So first of all, the primary reaction, like I said before, is something we call oxidative fermentation. It's not a very appropriate name, but that's a name we gave, which is due to the Enseniaspora valbiensis, apiculate yeast. Though this is a very short period. I said 1 to 2 weeks. The yeast lasts for 1 to 2 weeks. And it's able to generate some very interesting flavors, like flavored aroma, floral aroma or fruity aroma, depending the compounds. They're going to be the compounds which are going to be made. Then afterwards, the main fermentation is starting. Yeah. The main fermentation is starting, so the yeast, Saccharomyces uvarum, is going to take place. I added the Saccharomyces cerevisiae because due to the climate changes, sometimes in some cidery we can find some cerevisiae. Like I told you, probably that the cerevisiae is present in the cider, but due to the temperature we have, normally the uvarum will be selected naturally in the cider. Due to these climate changes and the high temperature we can have during the October or November period, sometimes we have cerevisiae which is developing. Well, uvarum is able as well to give some very interesting aroma. You can see pear, banana, fruity flavors. So that's usually what happens in the natural spontaneous fermentation. Yeah, another point is that very interesting during the fermentation, you will have the formation of CO2 that will protect the product from the oxygen incoming. We don't want to have oxygen during the fermentation. It's better to keep the oxygen away from the fermentation process to keep the quality of the product. So, like it was said before, one of the goals in the French cider fermentation is to keep the product sweet, and all year long. We want to have this type of product all year long. So the fermentation is not total. We still have sugar, and it's a long fermentation. Probably that's something different from the type of fermentation you have in America. The fermentation lasts for something like 2 to 6 months. To 6 months. It's very, very long, and we try to keep this speed of fermentation with low temperature. So the moderate speed is due as well to a low level of population, Saccharomyces uvarum, because like I said before, there is not a lot of yan in the apple, French apple. So if you don't have a lot of yan, the population of the yeast will be quite smaller, a lot smaller even. We never go over 10 to 7 UFC per milliliters. And there is one way to conduct the fermentation to slow it down is to get some biomass reduction. So we try to have a depletion in yan by getting out the part of the yeast. So in this case, as we have less population, we're going to slow down the speed of the fermentation. And this is the goal is to have to remove the yan from the cider. We don't want to have any more yan in the cider when we're gonna bottle it. That's for the stability of the product. So as well, I put on the slide reduction order. Be careful at this step. If there is too much population of Saccharomyces, when the fermentation is stopping, you will have a lot of sulfur compound generated in the cider, and in this case, you will have a reduction order. Now, we have the cider fermented. We have a period of what we call maturation. I don't know if it's a good word in English, but before bottling, we can keep the cider in vat for a certain time, and during this maturation period, we can have different other microorganisms that can grow in the cider. So I put here a cider with aroma, fruity aroma that we made with the different yeast. And during the maturation, we can have lactic acid bacteria growth, Enococcus honey, and we call this fermentation malolactic fermentation. And during this malolactic fermentation, we can have a buttery flavor that can be made that change a little bit the aroma flavor of your product. But the problem is that it will increase the pH because you are going to remove the malic acid, and so it's fragilized the cider. It's more susceptible to other bacterial growth like the Lactobacillus collinoides or some other unwanted bacteria. Another kind of bacteria that can grow, I talked about it earlier. It's acetic acid bacteria. This bacteria is able to generate some acetic acid, like I said, and gives some vinegar aroma to the cider, and it will mask the other flavor. So it's not something you really want. And as well, you can have during this period some development of Brettanomyces anomala. So this yeast is not wanted in French cider because that's something we have demonstrated in an experiment. It's gonna destroy the fruity aroma. That's one of these ability, if I can say like that. And then when the aroma is destroyed, it's gonna generate some other aroma that you don't want. We call animals flavor. To show you what we have demonstrated that is that we took a cider with aroma, fruity aroma at mid fermentation, that the graphic on the top, and we conducted the endogenous fermentation on the left, and the aroma decreased. So probably there is something happened during this fermentation, and we wanted to understand what was happening. So in the middle, we have added some Brettanomyces anomala in the cider, and what we showed that after a moment, the aroma were completely destroyed. The esters disappeared. On the other side, we added some Saccharomyces yeast, so Saccharomyces uvarum, and on the other side, Saccharomyces cerevisiae, and we saw that in this situation, the aroma was even increased. That was the work that demonstrated the impact, the negative impact of Brettanomyces. So we have to be very careful about this yeast, and that's one of the things we try to avoid in French cider. The main problem with this yeast is that it's going to use the phenolic acid present in the cider. The recommendation we give is that you have to avoid the rotten fruits. So we have to have a good selection of the fruits, and you have to use a good enzymes with absence of cinnamoesterase activity, because that's the activity that will release the precursor for the phenol volatile that Brettanomyces is gonna generate in the cider. So what is important at this level is really to be vigilant, to be looking at the lack of hygiene. So you have to be very, very careful about the cleaning procedure in your cidery. Equipment, but fruit as well. This yeast is even growing better when the temperature are higher. So it's more and more problematic with the climate changes. That's the reason why we recommend to our cider maker to work with low temperature, under 10 degrees Celsius. It's important to get rid of the oxygen, because this yeast is very sensitive to oxygen and will grow really faster with oxygens. Alors, I put nitrogen and sugar. Unfortunately, this yeast is very, very, how to say that, doesn't need a lot of nutrient to grow. So even in cider with low nutrient, with low sugar, low nitrogen, Brettanomyces will be able to grow. So that's the reason why all the other parameters I just listed are very important. The growth condition, I talk about temperature. This is a graph showing that the higher the temperature, the higher the speed of development of Brettanomyces. Usually we recommend to be under 8 degrees C to be, to protect the cider against the development of Brettanomyces. The technological means you will have to prevent this development is to go through a filtration, a very fine filtration, like cross-flow microfiltration. Eventually, if you have a cross-flow microfiltration during the fermentation, because this yeast can grow even during the fermentation, you probably have to, in this case, it's very particular, but in this case, you will probably have to inoculate a new commercial yeast to finish the fermentation. But it's not very easy in this case to finish the fermentation if you stopped it. But I mean, if you want to go through the fermentation for a dry product, you will probably have to, unfortunately, add some yeast. So just to remind some important parameters, at the end of the alcoholic fermentation, like I said to you, Saccharomyces uvarum will liberate CO2. When the fermentation ending, there is no more protection against the oxygen intake. So you have to be careful here. And what is possible is to go through the inerting of the vat by different type of gas. And probably, well, in this case, we can add as well sulfite and ascorbic acid. One of the options as well is to pasteurize the product. I mean, if you see that there is a deviation, off flavor coming, if you want to stop it, you can have these possibilities to really pasteurize the product to stabilize and to keep it clean. Last step, bottling. Before bottling, we will have to clarify again the cider. So why do you have to clarify it? Well, first of all, you want to have a clear product. Sometimes it's better for the consumer to have a nice product, limpid product with no deposit. So you have to clarify again your product. And that's going to stabilize as well the product from a chemical point of view, but for a microbiological point of view as well. You want to get rid of the microorganisms you can still have in your cider. So how to do that? settling, centrifugation, filtration. There is different options. You can have the fining as well. Usually we are using proteins like the gelatin, but there is some other options, other flocculant like bentonite, silica gels, and so on, even if the efficiency is not the same. After clarification, we're going to through the filtration step. There is different material you can use, either the filtration or Kesselger earth, or microfiltration, cross-flow microfiltration, sorry. There is different way to do the bottling in France. On the right, there is the main procedure is to have a final blend. So usually it's a mix of different cider. We have to equilibrate the sensory, the savor. Then a fining, and then a carbonation before bottling. When the carbonation is made, either you pasteurizing, the main procedure for industrial cider, or the small-scale cidery can make carbonation and can have pasteurization or not. Both ways are used now in France. And that another way, which is a little harder to make and to control, is to add yeast to make the carbonation in bottle. So we add yeast, we have a second fermentation in bottle, and that's it. So the process for, I will talk a little bit about the bottling with carbonation. So at this step, there is two different ways of doing. Either you have a flat product or a carbonated product already, and so you have two different kind of fillers. So atmospheric filler or isobarometric fillers. I won't go through that. It's not the purpose today. But at this level, what is very important for spontaneous fermentation is to avoid oxygen dissolution in the product, because you're gonna have some aroma impact of the oxygen in the bottle. And then we can have pasteurization, when I said. The second fermentation in bottle, the principle is to keep the CO2 generated in a closed bottle, but to keep as well the microorganisms. So you have to know the nitrogen quantity in your cider at the end to know the yeast, the quantity of yeast you're going to add in your cider. So there is different way of doing that, the méthode champenoise, clairette de Die, etc., etc. Why it's very important to be careful in the bottling? Yes, in the bottling is because Brettanomyces can grow as well in bottle. So that's something we show in some experiments, that the yeast can grow after 6 months, and you can see we can multiply by 100 to 1,000 the population in bottle, and in this case the aroma is gone. I'm gonna go rapidly because it's quite finished now. We just show the efficiency of the cross-flow microfiltration. For us, it's more efficient to go through the cross-flow microfiltration, because, like you see on the screen, the blue bar are the population at the beginning of the filtration. Then the others are through the filtration. So there is at the beginning of the filtration, when the first liters of cider are coming, then in the middle of the filtration, and at the end of the filtration. And like you can see, with Kesselger microfiltration, which is on the left, there is still some bacteria left in the product. With cross-flow microfiltration, that I call MFT, there is no more, there is one case of there is some Brettanomyces still present, but in 4 cases there is no more Brettanomyces, so it's more efficient. So that's a process that we recommended. To conclude, where the compounds are coming from, the interesting compound or the off-flavor compound are coming. So you have fermentative compound in the French cider. Some are coming, positive are coming from the oxidative yeast. You can see the acetate esters that we really want to have in French cider. Some other are coming from the yeast Saccharomyces, like alcohols, like ethylic esters. They can be, alcohols are precursor for the acetate esters. Unfortunately, you can have negative flavor during the fermentation that you should avoid. That the CSV, that's a sulfur compound that you have to avoid in the cider, reduction order. And the volatile flavor due to Brettanomyces yeast. So that's the part we try to avoid during the spontaneous fermentation. We have some other compound. We have some varietal compound that can be made in cider, in specific cider. The last one is a specific one. It's a cider which has those varietal thiol, those varietal compounds. They are specific. They give some fruity grapefruit aromas, citrus aromas. They are very, very interesting. We can have terpenes as well. That's something we just started to study. And those, well, there is some equilibrium interaction between the flavor compounds. It's very complex to study, but those varietal compounds can be liberated in the medium by some yeast. There is some specific yeast, no Uvarum yeast, but Saccharomyces yeast, Saccharomyces cerevisiae yeast that can help to generate those compounds. To finish, what is important to remember, there is a particular point you have to be really vigilant with. The cleaning procedure, to be careful about the fruit, the quality of the fruit. You should be very careful of your cidery cleaning on the vats, the transfer pipe, all the different equipment you're using. You have to really clean at each time you're using it. You should be really careful about the blend you're doing, because if you have a contamination in one cider, if you make a blending with other vat or other cider, you will cross-contaminate all your cidery, all your products. So it's very important to be careful and to know how is your product. Negative impact on aroma, that the bad food conservation, the microbial contamination, so you have to be careful about the temperature. What is positive? Usually it's to avoid sulfite utilization, but there is still a risk to have some other bacteria that will develop in your product. So why to avoid sulfite? In French cider, that's for the yeast I talked about earlier, Enseniaspora, which have a very important impact on aroma. In French cider, like I said, we have a lot of polyphenols, and we have an enzyme we call PPO, polyphenol oxidase. And this system will put the cider rapidly in anoxy. So we don't have oxygen very rapidly in the cider. And that's a kind of protection for the cider. Then the low temperature, again, we have to be careful. The variety of the fruit and the maturity should look at that to see how you can manage your fermentation. So the kiving is normally something very interesting for the flavor. When you have a good kiving, that's usually because Enseniaspora valbensis was developed in the product. That means that the aroma will be very good. And you have to be careful about the bottling, because it's the last step. When the cider is in the bottle, you have no more action possible. So you really have to be careful to the quality of the product you have in the bottle. Last point, I added this slide just this morning because I had discussion with some people in the room. You should really know the yarn composition of your must, because that will help you to know the speed of the how can react your cider, your must, how fast will be the fermentation process. So that's something you really have to know. Which level I have, because you will also know if you need to add some nitrogen in your cider or not. So that's a particular point. You should know the acidity of the product. Or usually you have a lot of acidic apple. What I saw yesterday in the tasting room, but you have to know where you are, because it's important parameters for the bacterial development. You should follow your volumetric mass. So that's something simple to follow, but like that you can see the speed of your fermentation, and you can control a little bit more the action you can have if you want to have a biomass reduction and so on. In France, it's what we are doing. We are following the volumetric mass to see if we have to make some process to control the speed of fermentation, which is very important, and it's not made even in France. We are really working on that to push the people really to go through that, is to have a microbiology analysis on your must or your cider to know if you have Brettanomyces contamination at least, because that can give you some information how to conduct or to manage the different cider you will have in your cidery, not mixing a cider with contamination. If you have a beginning of contamination, you can decide to pasteurize, filtrate, and so on. So that gives you real information to how to control your cider. To determine the strategy you have to have on your cider. Thank you for your attention. Thank you very much. I wanted to thank the organization for the invitation, for the very nice organization. It's very, it's a nice, very nice congrès for me. It's very interesting. So thank you very much.